Out in the vast and unforgiving deep blue ocean, colossal wind turbines stand as monuments of engineering, braving the elements to harvest the power of storms. These massive blades, stretching over 100 meters, slice through the air with incredible force, turning the invisible energy of the wind into usable electrical power. Deep within the heart of the nacelle lies the critical component, a drive shaft engineered to withstand extreme rotational forces and keep the entire system running smoothly. While the ocean's fury can toss massive cargo ships like toys, these turbines must remain absolutely stable, enduring pressures that reach up to several thousand tons daily. The immense pressure exerted on these components is staggering, requiring materials that can endure decades of constant stress without even the slightest hint of structural failure. To create the backbone of these green giants, we must go back to the beginning, where extreme heat and raw power transform solid metal into liquid fire. The rhythmic sound of the forge echoes through the factory floor, signaling the birth of a component that will eventually power thousands of homes across the world. This is the story of the drive shaft, a masterpiece of forging that acts as the backbone for the global transition towards sustainable and clean renewable energy. The journey begins with the selection of high-grade alloy steel, carefully melted in an electric arc furnace to ensure the highest quality for the final forged product. Molten metal flows like a river of liquid fire, reaching temperatures high enough to break down the very structure of the steel before it is reborn anew. Critical alloying elements such as chromium, nickel, and molybdenum are precisely added to the mix, providing the necessary strength and corrosion resistance required for marine environments. The liquid steel is poured into massive vertical molds, beginning the slow cooling process that will eventually form a single, solid ingot weighing over 100 tons. As the outer surface solidifies, the internal temperature remains incredibly high, ensuring that the crystalline structure of the metal forms uniformly throughout the entire heavy mass. A massive crane lifts the glowing 150-ton ingot from its mold, a colossal block of raw potential that will soon become a masterpiece. Still glowing at over 1,200 degrees, the ingot must be handled with extreme care to avoid any surface defects or internal structural inconsistencies. Heavy-duty transport vehicles move the massive ingot across the factory floor, their engines roaring as they carry the immense weight toward the next stage of production. The ingot is placed into a specialized soaking pit to ensure a uniform temperature from the core to the surface, preparing it for the upcoming forging process. Uniform heating is crucial. Even a small temperature variance could cause the metal to crack or fail due to the immense pressure of the hydraulic forging press.
Temperature holding steady at 1200
degree of
degrees.
temperature,
Confirmed.
ensuring the metal reaches
We have
its
green
peak
light.
plasticity before
Initiating
the true transformation
sequence.
under the weight of the press begins. The main event begins as a 15,000-ton hydraulic press descends, exerting a force so immense it physically reshapes the internal grain structure of the steel. Upon contact, the surface scale explodes outward in a shower of sparks, revealing the bright, glowing metal beneath as it yields to the machine's overwhelming power. Advanced robotic manipulators rotate the heavy ingot with surgical precision, allowing the press to strike from every angle and shape the metal into its primary form. The entire workshop vibrates with the low-frequency rumble of the press, a rhythmic dance between brute force and the fine control of modern industrial automation. What was once a short and stubby block is now elongated, transforming into the cylindrical shape that will eventually serve as the main axis for a turbine. This process, known as open die forging, eliminates any internal voids and ensures that the finished shaft possesses the ultimate strength needed to survive years of service. High-pressure water jets blast away the remaining skin, a necessary step to maintain a clean surface and prevent defects from being forged into the metal's body. Every stroke of the press is a calculated move, refining the dimensions and properties of the steel to meet the exacting standards of the energy industry. On a microscopic level, the steel's grains are being crushed and realigned, creating a dense and fibrous structure that is far superior to any cast metal part.
Rotating for the
Precision is
diameter
maintained
reading now.
even in this harsh environment, with
Steady.
engineers
We are
using
holding
laser
at
measurement tools
1.5
to
meters.
ensure the dimensions are
Confirmed.
correct while the
Logging
steel
the
is still
data.
hot. The coordination between the press and the manipulators is a feat of modern engineering, allowing for the handling of objects that weigh more than a skyscraper. Now the focus shifts to the flange, the critical attachment point where the turbine blades will eventually be mounted to transfer the wind's massive torque. Excess material is trimmed away with intense heat, leaving behind the pure, forged core that will go on to become a vital part of our infrastructure. After hours of intense forging, the shaft is moved to a cooling bed, where it begins its slow transition into a stable and solid state. Controlled cooling is essential to prevent internal stresses from forming, which could lead to cracks or structural failures once the shaft is put into active service. The rough, forged surface is a testament to the incredible forces it has already endured, a precursor to the extreme conditions it will face at sea. In the quiet of the night, the cooling shaft remains a source of intense heat, a sleeping giant ready for the next stage of its manufacturing journey. Engineers review the digital blueprints, ensuring that the forged piece perfectly matches the structural requirements calculated to survive decades of constant and heavy rotation.
That's a long way
This
down.
massive component,
We need to
measuring
check
over
the coupling
15 meters in
tolerance
length,
at the
is
end.
now ready for the critical heat treatment process that will finalize its material properties. The shaft is lifted vertically, a towering pillar of steel, prepared to undergo the most dramatic transformation of its life, the intense and sudden quenching process. As the hot steel hits the water, a violent explosion of steam erupts, signaling a rapid cooling that locks the carbon atoms into a hardened state. The rapid drop in temperature changes the steel's molecular structure from austenite to martensite, creating a surface hardness that is capable of resisting extreme wear. Emerging from the depths, the shaft is now incredibly hard, but also brittle, requiring a second round of heating to find the perfect mechanical balance. This molecular transformation is what gives the drive shaft its legendary durability, allowing it to hold up against the relentless torque of the ocean winds. Next comes the tempering process, where the shaft is slowly reheated to a lower temperature to relieve internal stresses and increase its overall toughness. This careful reheating phase is vital. It transforms the brittle martensite into a more ductile structure, ensuring the shaft can absorb shocks without ever breaking. Cooling after tempering is a more gradual process, allowing the metal to reach its final equilibrium and achieve the specified tensile strength and toughness. The transformation is now complete. The raw steel has been forged, hardened, and toughened into a high-performance alloy capable of facing the harshest ocean storms. Mass production of these giants requires a highly organized workflow where every single shaft is tracked and treated with the same level of scientific precision. The steel now possesses a unique blend of properties, a balance of hardness and ductility that is essential for the long-term reliability of offshore wind. Every sensor and fixture is removed, and the shaft is prepped for its final transition from a rough forged part into a precision-engineered machine component. Its sheer size is breathtaking, a testament to human ambition and our ability to manipulate the basic elements of the Earth to serve our energy needs. Born of fire and pressure, the shaft is now ready to be refined into its final polished form, where every micrometer counts toward its eventual success. We move from the raw heat of the forge to the clinical precision of the machining shop, where computers and diamond-tipped tools take over the job. On the massive CNC lathe, the shaft begins its final transformation as high-strength cutting tools peel away the rough exterior to reveal a mirror-like finish. The cutting action is relentless, with spiraling metal shavings peeling away like ribbons of silver as the lathe turns the heavy shaft at high speeds. Coolant flows continuously, keeping the temperature stable and ensuring the precision of the cut isn't compromised by the thermal expansion of the massive steel body. The result is a surface so smooth it looks like liquid metal, a necessary finish to prevent any stress concentrations that could eventually lead to cracks. This giant machine operates with a precision of less than 1/100th of a millimeter, a level of accuracy that is difficult to achieve on such scale. Next, high-precision drills create the bolt holes in the flange, which will eventually secure the giant turbine blades with absolute, uncompromising strength and stability. The sound of precision machining fills the air, a satisfying harmony of technology and metal working together to create something truly extraordinary for the future. A laser scanner meticulously maps every millimeter of the finished shaft, comparing the physical part to the original digital design to ensure absolute perfection in geometry. On the control screen, green highlights confirm that the shaft meets every rigorous standard, with zero deviations that could compromise the safety of the wind turbine. Every bolt hole and every surface curve is a testament to the precision of modern manufacturing, where giant parts are treated with microscopic levels of detail. Manual inspections provide a final layer of quality assurance, as experienced technicians use precision tools to verify the most critical dimensions by hand with care. A final polish brings the shaft to its peak aesthetic and functional state, ensuring that it is ready to be shipped out and installed at sea. Each shaft is laser engraved with a unique serial number, allowing its entire manufacturing history to be tracked from the original furnace to its final installation site.
Clear the lathe.
The machining journey is over.
Bring it across
What began
slowly.
as a 150-ton block of raw
Easy
steel
now, lower
is now
it
a
down.
high-precision instrument,
That's good,
ready
right
to
there.
begin its life at sea. Rows of these finished masterpieces wait for transport, representing the combined effort of thousands of engineers, metallurgists, and craftsmen working toward a common goal. Non-destructive testing using ultrasonic waves allows us to see deep inside the metal, ensuring there are no hidden cracks or impurities within the shaft's core. Magnetic particle inspection reveals even the smallest surface flaws, ensuring that every inch of the shaft is structurally sound and ready for the most extreme conditions. To survive the salt and humidity of the ocean, the shaft is wrapped in protective layers and treated with advanced coatings to prevent corrosion during its life.
Easy now, bring it
harbor,
down slow.
The shaft is
Watch
loaded
the
onto a
clearance on the
specialized
starboard
transport
side.
ship, beginning its final journey
All right,
to a
set
wind
it
farm
down gently.
located miles away from the coastline. Offshore installation is a delicate operation, requiring calm seas and expert coordination to fit the massive shaft into the waiting nacelle high above the water. Once secured, the blades are attached, and the heart of the turbine begins to beat, turning the wind into a steady flow of clean, renewable electricity. This is more than just industrial manufacturing. It is the art of forging a sustainable future, where technology and nature find a perfect, harmonious balance.